Solving absolute value equations. Absolute value means the distance from zero. Sometimes students think that it means to change the sign of something, but when we talk about absolute value, what we mean is how far away something is from zero. So in the case of -5, it's 5 units away from zero, so we would say that the absolute value of -5 is equal to 0. So when I have something that's in an absolute value equation, such as this one, what I want to do is I want to isolate the absolute value symbol so that I can think about it as being a distance away from zero. So for this example A here, I'll start by subtracting 8 from both sides. And so since we're saying that the absolute value is equal to 5, that means that this item, the 1 minus 4x, could either be in the position of -5 or it could be in the position of +5. Each of those items are 5 units away from 0. So I'm going to break this into two separate equations. Either 1 minus 4x is equal to +5, or 1 minus 4x is equal to -5. Let's subtract 1 from both sides. So then we have -4x equals 4, or -4x equals -6. Then divide by -4. So I'm getting that x is equal to -1, or x is equal to 3/2. Let's check our answers and make sure that they're correct. Looking back at our original, we had 1 minus 4, and let's suppose that we put -1 in its place, in the place of x. So in the absolute value symbols, I have 1 plus 4, which is the absolute value of 5, or 5 plus 8. That is equaling 13. So this looks like that is a correct answer. Let's check the other one, 3/2. If I put 3/2 into that place of x, we want to know if that's equal to 13. -4 times 3/2, let's see what that is -6. So I have -5 in the absolute value symbols. And then I'm getting 5 plus 8 again, and this is 13. So both of our answers are correct. Let's look at example B. For example B, even though I have a negative number on the right-hand side of the equal sign, we can still think about solving this problem. Absolute value always has to be positive, but I've still got this 7 that's sitting here, and when I add that to both sides, I'll end up with the absolute value of 2x minus 1 equaling a positive number, equaling 5. So now I will get rid of the absolute value sign and change this into two separate equations. 2x minus 1 is equal to +5, or 2x minus 1 is equal to -5. Both of these examples ended up having 5s in them. Let's add 1 to both sides. I'm just doing both of these equations at the same time here. So 2x is equal to 6, or x is equal to 3 is one of our possible answers. And then 2x is equal to negative 4. X is equal to negative 2. So we think that these are our two solutions. Let's check our answers. All right, let's check x equals 3 first. 2 times negative 3 minus 1. We want to know if this is equal to negative 2. Negative 6 minus 1. So this is, no. Why am I plugging in negative 3? I should have been plugging in positive 3. Let me go back. I made a mistake here because I can see that that wasn't going to work, right? Okay, so up here, I accidentally plugged in a negative 3 and it should have been a positive 3. So I've changed that, and that makes this a positive 6. All right, back on track. So the absolute value of 5 minus 7, we want to know if that's equal to negative 2. And it is. 5 minus 7 is equal to negative 2. So we know that 3 is an answer. Our second possible answer was negative 2. So let's check that one. Oops, let's check x is equal to negative 2. We have 2 times negative 2 minus 1. So negative 4 minus 1. And we're getting the absolute value of negative 5 minus 7. And so this is going to work. When I take those absolute value signs off, that's going to make the 5 positive, and we are getting that our second answer worked as well.